All right. Hi guys. So today we are going to continue on implementing chapter 8 of the book. Chapter 8 is about how to model variables in state. Go over there, statements and state. So last time we made the same helper data structure for an environment. An environment is
Okay.
a mapping of variable names to yeah, mapping of variable names to runtime values.
Okay.
And last time he talked about how nested scopes work in blocks and are implemented.
Mm-hmm.
So basically the an environment, it has a pointer to sort of the root environment that it's
Mm-hmm.
nested inside. And when you want to evaluate a variable name, so you start with a variable name, which is this key into this map here. First, you look in the innermost environment, which is going to be the environment that gets passed in here when you evaluate an expression,
Yeah.
and see if the variable exists there. If it does, you return the value. Otherwise, you go look in the enclosing environment and recurse on that. So it will
Mm-hmm.
go further up and up into the enclosing environments until it actually gets the variable. And if it never finds it, then that's an error. Okay.
Yeah.
So that's what we did last time. Today, I think I will try to plug that structure in to the evaluator for an expression. Because one of the cases that we skipped when we were writing this logic is
Mm-hmm.
if you reach an identifier in expression, this means you need to actually evaluate it using the environment. So right now that's skipped, but now I will try to implement it.
Okay. Is the environment mutable?
Yes, we get a mutable reference to the environment in this block of code.
Okay. Good.
Um, let's see. Actually, I guess so. This is all for an expression. So we're not going to be setting anything. I guess we have member assign. Interesting. Okay. So this
Yeah.
will,
Typically you distinguish expressions from statements,
yeah, that's right.
but
So
if all you have is expressions, then that's what you got to do. Have a mutable environment for the expression.
yeah.
If some of the expression is mutable.
Well, right. So that's what I was sort of looking at is like
Yeah.
if all we're doing here is getting the expression or evaluating the identifier, then this doesn't need to be mutable reference.
Yeah.
It depends. So I actually think before too long we're gonna make the like global function, this will become eval expr, and then this will expect a program or whatever the top level node is.
Okay. Yeah.
Yeah.
Okay.
But yeah. All right. So for now, okay. So this will be possibly just state dot get uh, name. Um, let's see. It doesn't like that because that's an option.
Okay.
Um, something like that. All right, now what do you not like?
Mhm.
Let's see. Okay, it's a reference. So maybe I need to clone it. That's just because of the way we've written this. This needs to give a new value, not a reference to a value.
Okay,
So the clone makes sense, I think. All right. I think we haven't gotten to classes. All right. So before we can do anything else, I think we need to write eval at a higher level. So this will be called eval expr. Rename symbol here. Changes the tests. Okay. All right. So let's see. I don't remember what the see. It's in the parser program. Thought we had a struct called program. Yeah. Okay. All right. So I don't know if this actually. Yeah, I kind of thought we had like in main, we had it. Okay, got it. Okay, so I can actually plug this in here. This is
okay,
um, our main can actually evaluate the entire file now, but let's just make it here. So let's say that we've already parsed it.
okay. You need to have the state.
I don't think so. So this is at the top level.
Yeah,
I don't think it's actually going to recurse on at this level.
yeah,
So we're going to be making the state here.
okay,
Um, like this. And then we'll pass it into the sub functions, but
okay,
yeah.
fine.
Okay, so let's see, so run. I think we probably just want to match the signature of run or if whatever this is, run file. Yeah. Okay. So I think that let's see, he probably also makes this part here. Let me just find where it is. Okay, so he has an interpret class, and the way he does it is an interpret of a list of statements. Okay, so let's stick to that actually. This will come later. And then print. Okay, and then here we can make the environment. Okay. Because I think the assignment is one of these possible statements.
Yes.
So fill match arms. Great. So I'm not seeing assignment statement here, and I kind of thought we did all of them.
Because that's an expression, wasn't it?
Yeah, that's right. That's right. Because you can like you can chain assignments and say like A equals B equals C. All right. So assignment is one of these. Guess it's a member assign, which is why we need mutable state here. Yeah, let's just try to do this. So interesting. So he doesn't have this fully fleshed out to member assign. So in the finished grammar, it has like a different structure. But this seems to be just kind of a basic assignment here. Okay. So this is parsing. And then what are you going to do here? All right. So let's I'm gonna do something silly for now. That is a vec member access. Okay, whatever. I'll get that later. State dot sign full path to value. Okay, that is a box expression. Got it. Okay. So we need to evaluate that expression. Okay, not much.
Oh, wait a second. The evaluation of the expression should return. Oh, okay. You modify the state. Okay, that's fine.
Yeah, it should give a value,
Yeah.
I would hope. Expected value found. So this expects a value. All right, so return V, I think, because that's how it ends up being nested.
Yes.
Okay. And this is a box. Let's see, let me get what's inside the box. It's been a while. kind of thought you could, there's a smart pointer, so yeah, okay. Use of moved value. Oh, well, that's annoying. So assign, we gave we made it consume this, got it, okay. But I don't want it to. Okay.
Mhm.
All right. I think these things we still don't know how to do because that requires knowing about functions, methods. That's class stuff. Okay. But we can write a test for this. Right. Let's see. So I guess we do two statements. So b equals 5. And then b equals 5. So assign, then use.
Mhm.
Okay. All right.
Yep.
So assign.
Mm.
So this will modify the environment.
Mhm.
Use REST. I need to do that. And then assert that it's true. So b equals 5 should evaluate to true once we set it in the environment. Let's see if it parses correctly and everything. All right. Lots of stuff doesn't like. Let's see if I can fix that by stopping importing this. Okay, still doesn't like that. Why? Because I think everything needs to be public now. And that's exported from here. Okay, so it's talking about declaration is private. So make you public. I might complain about something else. Yep. Like, all right, and that's all that it was complaining about. All right, we failed. It panicked somewhere. Panicked here. Okay, so we might need to debug some stuff. Okay, don't know how to do it. Yeah. Okay, let's see. So what happened was it got in here and then this was not true. So if let sum v equals that, assign it. Oh, right, because so this is because LOX treats it as two different steps. So assigning means that the variable is already declared, but we want define.
Oh, okay.
Yeah, that makes sense. Define. Okay, still wrong. Right? No, it's correct now. Okay, cool. All right. Let's see. Now what can we do? I guess in order to go any further, okay, we can do this. We can do this part. So I think up to this point in the book, he's talked about, let's see, only a few types of statements. He's talked about printing stuff and assigning stuff. Okay. Oh, and blocks, block statements. So blocks mean that you have to create a nested environment. Okay, so we will get rid of these. All of the ones he hasn't talked about yet. Hey, Michael. We've got the alien microphone disorder. A moment. All right. So we talked about print statements, expression statements, and blocks. And I think, let's see. You handle declarations here. No, still bad, I'm afraid. All right. Okay. So if, okay, it's obvious what to do with an expression statement. No. With an expression statement, we just call a val expr on the expression and pass in the state. Right? And now you're going to complain about the fact that this is in a box or something. Let's see. Expected, nothing, found value. Okay. So just run it and ignore the result. I don't know why Michael's leaving and rejoining. I think it's probably not a Zoom problem. Wish him luck.
Any better?
Yeah, that's better.
The shitty webcam that's 10 years old that I need to replace.
Yeah. Do you know what it sounds like when it messes up like that? Have you heard it?
No.
It's pretty funny. Sounds like Donald Duck or something.
Yeah, I think it sounds like a duck as well.
All right. So print statement. I didn't when I selected fill the match arms, it just put underscores everywhere. I have to go back and look at the actual enum. Let's see. The print statement has an expression. And I don't know if we generically know how to print a value, but I guess we can just derive, like, implement a trait for it or something. So we're going to evaluate the expression with the current environment, and then print the value. See, and yep, we don't know how to do it, so
I think we need to do pattern match on V and call the right print method.
sure. But shouldn't we just like implement the trait per value, something?
Yeah, we can implement display.
Let's see.
No, that would be the easiest is right F and something like this.
And it already covers all the cases because they already cover.
That's for number specifically. So
That's for numbers.
You will write this line in every number and string.
Okay, but does the same thing, but you just have to extract it. Sure.
For bool, is there a display for bool?
I would hope so.
I don't think there is display for bool. What is it complaining about?
It's not complaining about anything.
It's not complaining. Okay.
Cool. All right, and now we can just in print statements, print B. I guess, let's see. Whatever, the new line thing or not doesn't really matter. Okay. So if it's a block, this is a vector of declarations. Okay. So I think the idea here is make new scope. So let huge inner equals environment new state. All right. Mutably borrowed more than once. What are you talking about? Which are mutually exclusive. Oh, it's in a loop. Okay, got it. But it's still only once at a time. Right?
You have to link it to the old environment.
What are you talking? What are you saying?
You say for the new environment, you created the new environment. How do you link it to the old environment? To the current environment that you have?
Let's see what he does in the book.
Because
think-
there must be a linked list on that.
Yeah. So it's because this can contain a link to the previous one.
Okay.
So, but let me see how he does it. Because I expect that, yeah, somewhere he has to set the state to the inner.
Oh, okay. So it's I guess it's a method on the environment where you create a new one and return the new. Is it how it operates?
Here's what he does. So new is correct. That's and taking the enclosing environment and then putting it in.
Okay.
So what he does when he executes a block is he starts with this. Wait a minute. This dot environment. Okay, so this is inside the interpreter class. I went over this last time, but I sort of forgot. So he sets the interpreter's state, which is this,
Yes.
to the environment passed in. So you save the current state, call it previous.
Yeah.
Set this to the new state which you've just passed in. So that one.
Oh, okay. Yeah.
And then execute statements in the block. Well, this is sort of annoying because we have to account for declarations. No, whatever. Okay. I think at this point in the book, he is assuming statements and declarations are the same thing.
Yes.
Which
What is the block will have its own declarations. It's that will look at the new environment.
yeah, that's right.
Hmm.
No, I'm just talking in terms of the grammar. So
Okay.
we sort of follow the book in a weird order. So we basically implemented the full grammar from the appendix.
Okay.
But he's going back and forth between implementing a piece of the parser and a piece of the evaluator.
Okay.
But we have like the entire parser, and now we're writing pieces of the evaluator. So
Yeah. By
In
the
the
way,
f-
the parser is handmade, isn't it?
yeah.
Okay.
It's handmade, but with the help of some scary macros.
Okay. Yeah. But it's handmade. So I read there was a recursive descent thing.
Yeah, it's recursive descent. So let's see. So he's going to set the global state equals inner. Not assigned to state because it's borrowed. Yep. I had a feeling this would be annoying. And then for declaration
Mhm.
in body, gonna interpret declaration. I guess, oh no, interpret body because this is taking a vector of statements. And then that means, yes, we do need state, which is a environment.
Mhm.
Okay. So yeah, so this is the vector declarations instead of statements, which is going to be annoying, but we'll deal with it. And then this is okay.
You don't need to, you don't need to get that statement that state equals inner.
You are right. Yeah. So we're getting this passed in.
Yeah,
Going to interpret this with inner.
yeah.
And then, yeah, so you're right, because we're basically doing recursive descent instead of keeping state in a class. Yeah. Okay. That makes sense. Okay. So the only problem now is just that this is the wrong type here. Okay. Let's see. Does he handle variable declarations separately here? I guess he does. So we had, so here I was just trying to test it, but this should be assignment because this is an expression once you've actually made the variable already. And then in the grammar, the variable declaration part is handled differently, I think. So what do we get in here?
But yeah, you get the variable declaration, it's a statement.
Yeah,
So you don't need you don't need to worry about particular handling it particularly. It'll be handled as a statement.
um,
So what the block has is a bunch of statements.
yeah, right. So, I mean, there's something called a variable declaration statement.
Okay. Oh, okay. Yeah, that you have to deal with as
Yeah.
as an independent. And what that should do is add that variable to the environment, to the current environment.
Yeah, it should. I'm trying to figure out. So basically, I think, right, he's making some simplifying assumption or simplifications to the grammar here. He's neglecting that declaration is like a different class from statement. So, because he's going to add that later in the book. So, right, we're in the situation where these are declarations instead of statements, and then this one is a declaration instead of a statement.
Okay.
So I might be able to just deal with this one already.
Does it do because he puts all declarations before statements? That most likely is what it is.
So if it is actually a variable declaration, then we have the name and the definition. So if, or actually, wait. Do we already have this already take care of it? Yeah, okay. We can do, yeah. We can do let v equals definition dot unwrap or value nil. And then state dot assign, and no, wait, state dot define name v. Okay,
Mhm.
but we need to parse the expression.
Do you need to clone it also?
One sec. Wrap or expression. No, this is a silly way of doing it. There we go. So yeah, we need this is a maybe an expression because it could just be, it could be var a equals 5 or it could be var a. If it's this one, then we need to unwrap it. If it's this one, we need to make it nil. And then evaluate that and then assign it.
Do you need to clone it as you clone the other expressions as when you obtain the results?
Maybe, let's see, why did we need to do that over here? The only reason we need to do that is so that we can chain these. I expect that we probably do need to do that. So this depends on whether the syntax allows like var a equals b equals 4. So if that's allowed, then yeah, we do need to clone it. But just from the way the grammar is structured, doesn't seem like it. I should probably, sometime soon, we should get a real LOX interpreter so we can compare results. I'll do that next time. All right. So let's get declaration. Okay. Let's see, is there anything else? So because we just recurse here, I do think that we don't need to do any of his setting of some state in a class or anything. So all that's going to happen is we're going to have a thing at the top level, like I was saying, which returns a result. And then this will make the state. And then parse the program. All right, All right. And then so all that scope nonsense will be handled by just doing it recursively. Okay. Empty statement, I don't know. I guess don't do anything. Who knows?
Yeah. It just what do you return for? It's going to be the same environment that what you return.
What do I return for interpret? Probably a result.
Yeah.
All right, let's see if we can deal with some of this annoyance. So if I'm gonna write the evaluation logic from the beginning, I sort of need to just match the structure of the grammar. So in the grammar at the top level, we have this. And so really we need to interpret a vector of declarations, not a vector of expression of statements.
Mhm.
So what can a declaration be? Any of these?
Okay, the declaration has the statement in it.
Yeah, that's right. Good. Just because it's at a higher level in the grammar.
Yes.
So let me do that. The declaration. This is really where it should be for our logic. So you are called declarations. You are called declaration. All right, come on. Declaration. You remember you. Somewhere. Okay, and then fill the match here. So we're not doing classes or functions yet. I guess I'll just leave them to do. A variable declaration, we already knew how to handle. That. Oh, okay. We are already in that case. Okay. So declaration statement, that's where we need this. Interpret statement. State is a environment. And this should just do this thing. All right. Not declared as mutable. What are you talking about? Okay, so what are you talking about here? Try removing mute.
Can you show the full error message?
Yeah. Okay.
I already passed it as a mutable reference.
I got it. Okay. So simple.
Mutable reference to mutable reference doesn't work.
So just keep passing it down, I guess. And then
Yeah.
this thing, now we're running into the lifetime problem. So
Okay. So what's environment?
that's our struct.
And why do we need to make a new one?
For the scope thing. This is a new scope.
Can you show me environment declaration? Yes, so we. That looks like. Yes, my reference. Environment A.
You want to look at the error again? Lifetime may not live long enough.
Okay, let's add lifetime annotation to the interpret statement function.
Okay.
And we need to introduce it, and the environment structure itself takes a lifetime.
So now it's okay with that. It's just not okay with how we're using it. Okay. Probably got to do the same here.
Yeah, you just need to explain that those two are the same. State.
But now it's running. Now it has a problem that I'm doing this in a loop.
Well, it's not about doing it in a loop. We create V that captures environment, and then we call this. We're trying to use state with V, and V still holds the state.
Mm-hmm.
So I guess we need to finish V to the point that it doesn't hold the state.
Okay.
So V is what, a value? No.
Yeah. Yeah, it's a value.
Okay, well, it shouldn't. Cannot. 116 divided with A.
Why would it also be complaining about this?
It will complain that you're not handling all the cases.
Still a problem? No, it's a problem here. Hmm.
Again, the full error message. Okay, statement is A. Inner borrows state. Interpret. Argument requires that inner borrow. Okay, what's type signature for interpret? Declaration state environment. Okay. I think we need to explain that lifetime captured inside the environment lives longer. Maybe.
Okay.
So if you define a new lifetime, say B on line
Mhm.
135,
135.
yeah. So A and B, and call environment one of those lifetimes A, one of those B. And no, not here. On line 135 still. So go to the enter to change one of those to B.
One of them.
Yeah.
Okay.
Okay.
So this is a reference with one.
And probably to interpret as well. The same.
So yeah, so what we're trying to explain here
That
is that,
you can drop state without dropping whatever is inside.
yeah, or you can drop inner without dropping state.
Yeah. Okay.
So wouldn't that be in the definition here, something?
Possibly. No, that's not going to work. It's 8 already.
Yeah. All right. Well, that's a fun place to stop. Well, next time we'll figure out how to nest scopes.
Yeah, if you can push it,
Russ.
I can play around with it.
Yep. Yeah, I feel like that has some good progress. We matched the structure of the program for evaluation. Okay, cool. Okay. I will go ahead and stop recording.